I'm seeing a problem. My ElasticNet model has high bias. That means it's too simple and doesn't fit my data well enough. I need to make it more complex. Think of it like trying to fit a straight line through a bunch of scattered points that clearly curve. It won't work well. Let's fix this. This is the core of the quiz. I need to choose the best ways to tweak ElasticNet's settings, alpha and L1 ratio, to reduce the bias. I'll need to understand how these settings affect the model's complexity. The overall goal is to tune ElasticNet's hyperparameters, which are essentially the knobs I can turn to adjust the model. In this case, I'll focus on alpha and L1 ratio. I see this option suggests increasing alpha. Remember, alpha controls the strength of regularization in ElasticNet. A larger alpha means stronger regularization, which simplifies the model. This will likely increase the model's bias, making it worse because we are already dealing with high bias. So, this is not the right choice. Here, we're talking about decreasing L1 ratio. This parameter balances L1, lasso, and L2, ridge, regularization within ElasticNet. A smaller L1 ratio means we're moving more towards ridge regularization. Ridge regression generally has lower bias than lasso. That means this choice is likely to reduce bias, which is what we want. Decreasing alpha is exactly what we need to fight high bias. Recall, a smaller alpha means weaker regularization, allowing for a more complex model that will better capture the data's nuances. This will directly reduce bias and improve our model's fit. This option suggests increasing L1 ratio. This pushes us more toward lasso regression. Lasso often creates simpler models by setting many coefficients to 0. This can increase bias, which is not good for our high bias problem. We should avoid this option. I see a problem here. The ElasticNet model has high bias, meaning it's too simple and underfitting the data. We need to make it more flexible. My goal is clear. I want to reduce the bias by carefully tweaking the hyperparameters of the ElasticNet model. This involves finding the right balance between model complexity and accuracy. Alpha controls the overall strength of regularization. A large alpha means strong regularization, making the model simpler but possibly increasing bias. A small alpha means weak regularization, allowing a more complex model that might fit the data better and decrease bias. Let's look at the possible ways we can adjust our hyperparameters. We have 4 options to consider. This is what I'm aiming for. A solution that reduces the bias of the model and improves its performance. I'll focus on approaches that achieve this. This is what I want to avoid. Increasing bias means making the model even simpler and less accurate, so I'll reject any approaches that lead to this. By decreasing alpha, I weaken the regularization. This allows my model to become more complex and potentially reduce bias. This is a good option. Lowering the L1 ratio moves the model towards ridge regression. Ridge regression typically results in less biased models than lasso, which is what you get with a high L1 ratio. This is also a good choice. Increasing alpha will strengthen the regularization effect, making my model simpler and likely increasing the bias. This would make the problem worse. Increasing L1 ratio pushes my model toward lasso regression, which can lead to higher bias. I need to avoid this. We're tackling a problem where an ElasticNet model, a type of regression model using a combination of L1 and L2 regularization, suffers from high bias. This means it's too simple and underfits the data, failing to capture its complexities. My goal is to find the best hyperparameter adjustments to fix this. We'll focus on the alpha and L1 ratio parameters, which control the regularization strength and the L1 per liter 2 balance, respectively. I'll explain how adjusting these parameters can improve the model's ability to accurately represent the data. I've got an ElasticNet regression model, and it's performing poorly because of high bias. This means the model is too simple, missing important patterns in the data. My challenge is to improve its accuracy by reducing this bias. I'm looking at 4 options for adjusting the hyperparameters of my ElasticNet model to reduce the high bias. Each option involves changing either alpha, the overall regularization strength, or L1 ratio, the mix of L1 and L2 regularization. I'll evaluate each one to find the best adjustments to make. Increasing the L1 ratio parameter pushes the model towards lasso regression, pure L1 regularization. Lasso tends to produce simpler models that can have more bias. Therefore, this option is unlikely to reduce the bias. This is incorrect. Decreasing the alpha parameter reduces the strength of regularization. A weaker regularization allows the model to become more complex, potentially reducing the bias and improving its accuracy. This is a correct option. Increasing alpha strengthens regularization, forcing the model to become simpler. This will likely increase bias, making the model even worse. This is incorrect. By decreasing L1 ratio, I'm moving towards ridge regression, pure L2 regularization. Ridge regression generally produces less biased models than lasso. Therefore, decreasing L1 ratio is likely to improve model accuracy. This is a correct option. To successfully reduce the high bias, I must select all the options that weaken regularization and result in more complex models. We're tackling a problem where my ElasticNet model, which I use for regression, isn't performing well because it has high bias. That means it's too simple and misses important patterns in the data. I need to figure out how to adjust the model's settings to fix this. This is one of the right answers. The alpha parameter controls how strongly the model is regularized. By decreasing alpha, I'm reducing that strength, allowing the model to become more flexible and complex, which can reduce bias. Another correct answer, L1 ratio, balances two types of regularization, L1 and L2. L1 tends to create simpler models, with some coefficients equal to 0, and L2 tends to produce models with all small coefficients. By decreasing L1 ratio, I'm shifting towards L2, reducing the chances of a too simple model and therefore less bias. This is my question. I'm looking for the specific tweaks to the ElasticNet model's hyperparameters, alpha and L1 ratio, that will most effectively reduce its high bias. This means making the model more complex. We're tackling a problem, high bias in an ElasticNet regression model. That means my model is too simple, and I need to make it more complex to improve its accuracy. To do this, I'll adjust ElasticNet's hyperparameters, alpha and L1 ratio. This involves understanding how these parameters influence the model's complexity and bias. I have a problem. My ElasticNet model is showing high bias, which means it's underfitting the data. I'm not capturing the data's complexity. That needs fixing. My goal is clear. I want to reduce the bias in my ElasticNet model. To accomplish this, I'll strategically tune its alpha and L1 ratio hyperparameters. These are the settings I can tweak to change how my model behaves. We'll focus on the two most important ones for this problem: alpha and L1 ratio. Alpha controls the overall strength of regularization. Think of it as a dial controlling how much my model is simplified or regularized. A higher alpha means more regularization, a simpler model with potentially higher bias but lower variance. Conversely, a lower alpha means less regularization, a more complex model potentially leading to lower bias but higher variance. L1 ratio, ρ, determines the balance between two types of regularization: L1, lasso, and L2, ridge. Think of this as a slider, deciding the contribution of these two approaches. L1 ratio of 0 is pure ridge, while 1 is pure lasso. Lasso creates simpler models, sometimes at the cost of increased bias. Here are a few options for changing my hyperparameters to see which ones help reduce the bias. We will examine the impact of each choice. Increasing L1 ratio pushes my model towards lasso, which tends to increase bias. That would make the problem worse. So this is not a good option. Decreasing alpha weakens regularization, which makes my model more complex and helps reduce bias. That's what I need to fix my high bias problem. This is a good choice. Increasing alpha strengthens regularization, which makes the model simpler and likely increases the bias. Not helpful for my situation. Decreasing L1 ratio shifts my model more towards ridge regression. Ridge is known for having lower bias than lasso, so it improves my model by reducing bias. This is a good option. We're tackling a problem, Our ElasticNet model shows high bias, meaning it's too simple and underfitting the data. We need to adjust ElasticNet's settings, hyperparameters, to fix this. Specifically, I'll focus on how to reduce bias. I have an ElasticNet model for regression, and it's not working great because of high bias. This means the model is too simple and can't capture the data's complexities. It's underfitting. I need to adjust ElasticNet's settings, called hyperparameters, to decrease this bias. Two important settings are alpha and L1 ratio, which control the model's complexity. Changing these will either reduce or increase bias. Increasing L1 ratio makes the model more like lasso regression. Lasso often leads to higher bias because it forces many model coefficients to zero. So, this is a bad idea for fixing high bias. This is a great idea. Decreasing alpha weakens regularization. Regularization simplifies models and can cause high bias, so reducing alpha will allow for a more complex model, thus reducing bias. Increasing alpha strengthens regularization, which makes the model simpler and increases bias. That's the opposite of what we want. This is another excellent adjustment. Lowering L1 ratio makes the model more like ridge regression. Ridge generally has less bias than lasso, so this helps reduce our bias problem.